Hello students, this is the second class related to the problems on ray optics. Today I will continue the discussion of the problems related to lenses. Already in the last class I discussed 8 problems. The 9th one, a beam of light converges at a point P. Now a lens is placed in the path of the convergent beam 12 cm from P. At what point does the beam converge if the lens is a convex lens of focal length 20 cm and B, a concave lens of focal length 16 cm? Okay, problem related to lenses or lens formula. Okay, that in particular lens formula, not lens maker's formula, lens formula. Now, this is the 9th problem. A convergent beam is there. And 2 different cases have been given. Initially, in the path of the convergent beam, a convex lens is introduced. In the absence of this, these 2 rays would have converged at some point. This would have been the point of convergence. But because the lens that I have introduced, basically the rays converge at a nearer point because convex lens is a converging lens. It increases the convergence of the rays. Okay, that's why instead of converging at the point P, the rays will converge at the point P dash. Okay, this is what you have to consider. Now, the point P, where the rays would actually converge in the absence of the lens, basically becomes the position of the virtual object. Okay, this both the point will be the position of the virtual object, and this one becomes the position of the real image. Okay, therefore, this is U, and from here to here, that is whatever distance that we come across is one. Okay, this is the first case, that is A, and here the lens is a convex lens of focal length 20 centimeter. And in fact, it has been given that this distance is equal to 12 centimeter. It means the point P is basically at a distance 12 centimeter from the point P or from the lens. Okay, therefore, we have been given with U, we have been given with F. Our job is to find out V. Okay, this is the first case. But in the second case, they are introducing a concave lens in the path of the light. In the absence of this concave lens, the rays would converge here. Already you know the lens here is the concave one, which is a diverging lens. Therefore, it reduces the one, and thereby the rays will be made to converge at some point here. Okay, therefore, this is P, this becomes P dash. But this distance remains U, which is 12 centimeter, but this distance is now V. Okay, this we have to find. In fact, the formula for this one is already mentioned. It is lens formula, that is 1 over F is equal to 1 over V minus 1 over mu. Let us simplify the formula because we need V. Okay, therefore 1 over V, if I write, it becomes 1 over F plus 1 over mu. Therefore, V becomes equal to UF by 2 plus F. Okay, this is the simplified formula for image distance. If you can directly remember, it's well and good. Otherwise, write this and write the simplified formula. Okay, now let us consider the first case. And in fact, the second case, if we consider the focal length, it is 60, and this is minus 60. Minus 60 only because it is a diverging lens. Here it is plus 20, converging lens. Okay, you have to consider the Cartesian sign convention every time. Okay, don't forget to consider the sign convention. Okay, now in the first case, if you consider V, U is 12. In fact, this should be 1. Therefore, the distance is in the direction of the incident light itself. Therefore, 12 into F, which is 20, divided by 12 plus 20. Therefore, it is 240 by 32. Okay, once you simplify this, it comes out to be 7.5 centimeter. That means instead of the point P, it is converging at P dash, and P dash is at a distance 7.5 centimeter from the convex lens. The same thing we have to do for this. Therefore, in case of this B, the U is 12 again, but now it is minus 60 divided by 12 minus 60. Therefore, it is minus 12 into 16 divided by minus 4. Therefore, it is 48 centimeter. Therefore, it is clear, even though we are using concave lens, it is producing real image because the object is virtual. Okay, in case of virtual object, is it possible to get real image? The best example is this one. But in case of convex lens, okay, you can get virtual images as well as real images. Okay, even for real objects only, depending on the position. But here, for virtual objects, we get the real image only, and that's why we are getting positive value. That is 48 centimeter. Therefore, image will be formed at 48 centimeter from the concave lens. Yes. Here is the next one. Take this screenshot and move on to the next problem. Tenth problem. The radii of curvatures of two surfaces of a convex lens are 0.2 meter and 0.22 meter. Find the focal length of the lens if refractive index of the material of the lens is 1.5. Also find the change in focal length if it is immersed in water of refractive index 1.33. This is from June 2018 question paper. Okay, let us try to represent the problem diagram. The radii of curvature of two surfaces of a convex lens. It is a convex lens. One surface is having radius of curvature that is plus 0.2 meter, and the second one is equal to minus 0.22 meter. I am applying Cartesian sign convention. We have to calculate the focal length in A. Refractive index of the material of the glass, its length is big one and it is 1.5. Afterwards, the lens is placed inside water. That is, Ng is 1.5, but NW surrounding medium is 1.5 and refractive index 1.33. The same lens, and we have to find out F in water. A focal length in water is needed because we have been asked to calculate delta F. A change in focal length has been asked. Okay, therefore, change in focal length we can calculate only by knowing this. Okay, that's why delta F concept. Okay, now we know lens brightness formula, but for A it is Ng minus 1 into 1 over R1 minus 1 over 2. Now, 1 by F in A is equal to 1.5 minus 1 into 1 by 0.2 plus 1 by 0.22 minus of 0.22. Minus 0.22 is there. Therefore, once I substitute, it becomes less here. Therefore, it is 0.5. This is 0.22 plus 0.2 divided by 0.2 into 0.2. This is 1 over F here. Therefore, F in here becomes equal to 0.2 into 0.22 divided by 0.5 into 0.42. We have to simplify this one. And on simplification, we get 0.2095 meter. Okay, this is the focal length of the given lens in air. In air, this is what we are getting as the focal length. Now, once we place the lens in water, here we get Ng by Nw minus 1 into 1 over R1 minus 1 over R2. Okay. If you want, you can substitute here itself. Otherwise, you can just find out the ratio and you can avoid the substitution of R1 and R2 values. If you don't want to do that, substitute the values of this and you will be getting F water. Afterwards, you can find out the difference. Okay, whichever method you want, you adopt, but two options are available. Okay, whichever you feel easy, you go for it. Okay, now once you find out the ratio, it is 1 divided by 2 gives F in water by F in air. Okay, this by this. Okay, therefore F water comes here, F air. But this is Ng minus 1. This is Ng by Nw minus 1. Substitute for this. And this is 1.5 minus 1. This is 1.5 by 1.33 minus 1. Therefore, F in water becomes equal to F in air. It is 0.2095 into 0.5 whole divided by, on simplification of this, we will be getting 0.127. Okay. And the answer is 0.528248 meter. This is the simplified value of the focal length that you get. 0.8248 meter is the focal length in water. Therefore, remember, initially we have placed this in air, but afterwards we are placing the same length in water. And once you observe this, because of this one, here only Ng is there, where Ng by Nw. Therefore, this factor becomes less. And thereby, focal length meter, that is water, will be more. That means it increases. But another important point you have to remember. When I say 1.5, it's 3 by 2. 1.33, it is 4 by 3. If those values are there, basically if you consider this one, okay, it is 3 by 2, 4 by 3, therefore you will be getting 9 by 8. Therefore 1/8 you will be getting. That means focal length in water becomes 8 times the value in air. Okay, especially if they give NW as 4 by 3 and NG as 3 by 2 or 1.5, then basically focal length in water will be 8 times focal length in the air. Remember this idea. Okay, this holds good only if these values are given. Okay, or it will be nearly equal. Okay, ಹಾಗಾಗಿ especially in competitive examinations, you can easily identify the answer. Okay, it means in water, focal length will be around 8 times the focal length in air. And in fact, delta F in what? Delta F is equal to F in water minus F in air. That is 0.8248 minus 0.2095 is 0.6152. This is the change in focus. This is the value of the change in focus. Very, very important problem. Let's quickly take the screenshot. Next one. Now, an object of 3 centimeter is placed 14 centimeter in front of a concave lens of focal length 21 centimeter. Find the position, nature, and size of the image for. This is from July 2019 question paper. An object of 3 centimeter. Here is a concave lens. Focal length has been given as 21 centimeter, therefore minus 21 centimeter. But the 3 centimeter object has been placed at a distance 14 centimeter from the lens. Okay, it is negative because it is on this side. Okay, to the left. Okay, therefore the direction of measurement which has to be done from the optic center will be in a direction opposite to the direction of the incident light. Therefore minus 14. We have been asked to find out the position of the image. That means we have to find out the nature of the image, and also size of the image, which I have to find out. Object height has been given, but we have to find out image height also. Okay, this is the problem that we have to work. Now, again, it is a problem based on lens form. Therefore, 1 over f equal to 1 over b minus 1 over u. Already I explained v comes out to be uf by u plus f. Now u is minus 14, f is minus 21 divided by minus 14 minus 21. Therefore, it is 14 into 21 divided by minus 35. This is minus 8.4 centimeter. That means p value we are getting negative. That means the image is being formed on the side of the object itself. Object side alone it is not being formed here because it is a diverging lens. It produces only virtual images. The real object is there, therefore virtual image will be right. Okay, in fact, you will be getting a diminished virtual image. Okay, in case of the concave lens. Okay, irrespective of the position, in case of concave lens, you always get virtual images only. Okay, especially for real objects. Already -84. Therefore, virtual image is formed at 8.4 centimeter from the lens on the side of object is just write virtual image, it is sufficient, but I'm giving the complete idea. Now our job is to find out height of the image. Magnification, if you consider, it is HI by HO, and in case of lens, it will be equal to V by U. That's why height of the image becomes equal to HO into V by U. For HO, 3 centimeter, D minus 8.4, U is minus 4. Therefore, it comes out to be 1.8 centimeter. The value I am getting because all virtual images are erect. In case of height, if you get negative sign, it is clear it is inverted image. Positive value we are getting, therefore it is erect image. That's why I have written like this. Okay. Erect image you are getting, but it will be virtual. Yes. Taking the screenshot. The number. Okay, this 11th problem. Going on to the next. This is from March 2014 question paper. Two convex lenses of focal length 0.2 meter and 0.3 meter are kept in contact. Find the focal length of the combination. Calculate the powers of two lenses and combination. So this is the problem. This is the 12th problem. Lenses have been placed in contact. Actually, what are convex lenses? One is 0.2 meter, another one is 0.3. Both are convex, therefore positive. We have been asked to find out the focal length of the combination. That is F equivalent equal to another F1 plus equivalent by F1 plus F4. This is another formula. In fact, derivation is also there in theory. It can be asked for 3 marks, and if additional question is asked, it will be for 5 marks. F equivalent F1 F2 by F1 plus F2. So, F2 plus point. Therefore, it is 0.06, 0.5. Therefore, 0.12 meter. This is first part of the problem and it carries 2 marks. Formula 1 mark, substitution with answer 1 more mark. But I have been asked to calculate the power of the lenses and also the combination. P1 if we consider, therefore it is 1 by 0.2. But here you have to be careful. If the focal length is in centimeter, first job is to convert it into meter. If only when focal length is in meter, you can use this one. 1 by 0.2. Therefore, it is 5. The second one, 1 by f2, which is 1 by 0.3. Therefore, it is 3.33 there. Finally, power of the combination is consider P equivalent, which is 1 over F equivalent. In fact, you can find out this in this one also. P1 plus P2. Okay, because already we know individual powers. Therefore, equivalent will be the sum of the powers. Okay, therefore, one either you use this or this. Okay. Now, if you use this 5 plus 3.33, therefore 8.33 will be the power of the combination. 1 mark each. Formula with final answer gives you 1 mark. Yes. Let's move on to the next one. Is 13th problem. Read the problem. This is from textbook. The image of a small electric bulb fixed on the wall of a room is to be obtained on the opposite wall 3 meters away by means of a large convex lens. It means 3 meters is basically the distance between the two walls and one opposite walls. That too. On the first wall, a small electric bulb has been fixed. We have to get the image of it on the opposite wall, which is at a distance 3 meters. But now we have to introduce a convex lens. But we have been asked to calculate the maximum possible focal length of the lens required for the purpose. Maximum focal length of the lens that is needed to get the image on the other, that is opposite wall, when the distance between the walls is 3 meters. Therefore, this is 13th problem. Here is one, and on this one, bulb is there, which is the object that we have been to calculate F maximum, so that we get the image on this one. This distance they have given. This is 3 meters. But this distance is u. But this distance is v. But once you observe the diagram, it is clear this t which I have written becomes equal to 3 minus. Because this is 3, this is u, therefore v is 3 minus c. Let us consider the lens formula. 1 over f is equal to 1 over v minus 1 over u. In fact, we will get f is equal to uf by u plus. Sorry. Since I am simplifying for f equal to UP, okay, by u minus v. Practically becomes more clear. Here comes u. Therefore, f becomes equal to uv by u minus v. Now, focal length f is equal to. But once you consider this u, it has to be negative. Take the same convention. Therefore, minus c into v. What is the value of v? But 3 minus divided by minus u minus 3 minus. Therefore, f becomes equal to minus 3u plus u square divided by 3. But minus 3. Therefore, it becomes 3 sorry, u minus u square by 3. This is the formula for focal length in terms of u that we are getting. What actually have been asked to calculate? Maximum focal. Already it has been given that this idea has been given in mathematics. Whenever the quantity is maxima or minima, the differentiation of it will be 0. Therefore, once you consider f to be f maximum, df by d, okay, u has to be equal to 3. So this is the case. This differentiation of f with respect to u should be equal to 0. That is what we have to do. Now, but we want f is equal to f is equal to f maximum. Okay, df by du has to be 0. Therefore, differentiation is 0. This is 1 minus this is 2 by 3. Therefore, 2u equals 3, u equals 1.5. U will be equal to 1.5 or it will be equal to 3 by 2. This will be the value of mu once f becomes f maximum. Okay, therefore, focal length of the lens f becomes equal to u is 1.5 but minus 1.5 into this is 3 minus 1.5. Okay, that is 1.5 AB divided by minus 1.5 minus 1.5. Therefore, it comes out to be 0.75 meter. Maximum focal length of the lens that is required is 0.75 meter. This is the answer. This is the textbook. With the screenshot. Yes. The next one, the last one related to lenses. It is focal problem. A screen is placed 19 centimeter from an object. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeter. Determine the focal length of the lens. Here is an object. So this is the object. But the screen is here. And the distance between these two is usually considered as capital D and given as 0.9 centimeter. But the convex lens is there. Initially, when the lens is placed at a point close to the object, the rays coming from the object will converge onto the screen and we get the image. Okay, this is position 1. And they have given the idea that once the lens is shifted to a new position, and this is the second position, but the separation between these two is given by the symbol S, and this distance has been given as 20 centimeter. And here also, the rays coming from this is basically the diagram. But one point you have to remember. For the first position, object distance is less, image distance is more. Magnification, when you consider, it is hi by h0 and it is equal to v by real. But in the first case, for the first position, v is more, u is less. Therefore, for this position, we get magnified image. When the lens is close to the object, screen will be at greater distance and magnified image will be better. But for the second position, u is more, but v is less. Therefore, for this position, we will be getting diminution of image. Okay, therefore, at one position we get magnified image, at one position we get diminished image. But another important point you have to remember, okay, this problem is important for competitive examinations. Okay, in fact, you can derive the expression also, but I am not going for the derivation. But before going to the derivation, one important thing is, if you consider this D, if this distance is less than 4 times the focal length, if f is the focal length of the lens, if we consider the distance between the object and the screen, whose value is less than 4 times f. For example, if the lens is basically a focal length, say 30, what will be the value of 4f? 4 into 30 is 120. If you consider the D, here it is 90. Therefore, this D will be less than 4 times 10. Once we get this one, okay, no image can be produced, but can be obtained on the screen. That means whenever you want to get the image on a screen, image of an object on a screen, the distance between the object and the screen should always be greater than 4 times the focal length of the convex lens that we are using. Okay, in previous observe ಮಾಡಿದ್ರು ಕೂಡ ನಿಮಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. The distance is less than 4f, no image can be obtained on the screen, irrespective of the position. And then ಎಲ್ಲಾರು place ಮಾಡಿ, you won't get the image. But if D is considered just equal to 4f, it's exactly if it is 4f, then 1 v real images are one real image is time, okay, with lens or with v is equal to each is equal to 2. Exactly at the center point, lens will be there, and you will be getting one real image only. But if D is greater than 4F, in this case, two real images will be given. Basically, this corresponds to some. Therefore, we can understand easily that this 90 centimeter is more than 4 times the focal length. Focal length of the 4 times the just there. And whenever D or D greater than 4F, formula for F is D square minus A square by 4D. Remember the formula. D square minus A square divided by 4D. In fact, you are calculating the focal length by this method in the previous series. Basically, we call the method of finding out the focal length by using this as shift method. This is the first position. We shift the lens to this one. Okay. Once we know the distance, the shift produced in the lens to get the second real image, we can find out the focal length using the formula D square minus A square by 4D. Okay, this is the one that you have to remember. Now, F is equal to D square minus A square. D square is 90 square minus A square is 20 square by 4 into 9. This is 8,100 minus 400. This is 3,360. Therefore, on simplification, it will be 21.9 centimeter. This is the value. F value is 21.39 centimeter. Yes. In fact, optical instruments have been discussed. And in each, you have to remember the formula for magnification. Therefore, and already in theory examination, write the expression for magnification in case of simple microscope, compound microscope, explain the terms. Okay, definitely they can be asked. Already, I think 1 or 2 times the question has been asked also. Okay, that's why I'm discussing problems related to the formula involved corresponding to optical instruments. Okay, let us first of all consider a problem related to simple microscope. Okay, this is the 15th problem. A simple microscope produces virtual image of magnification 8. 15th problem is based on simple microscope. Magnification has been given as 8. And the image is being obtained at D, which is nothing but least distance of distinct vision. It means minimum distance at which we can see an object clearly. It will be varying from person to person, but for a normal person, its value will be around 25 centimeter, and the value of D has been given as 25 centimeter. This image is being obtained at least distance of distinct vision, and our job is to find out the focal length. This is first part. Focal length. focal length we need. But in the second case, also find the magnifying power. That means we have to find out m. If the image is obtained at infinity, that means v infinite. Okay. Focal length will be having from this one. Okay, therefore m we have to calculate for v equals infinity. That means final image, if it is obtained at infinity, okay, the eye will not be experiencing extra stress, because once we have to focus to a distance that is 25 centimeter continuously, okay, strain will be produced. Okay, therefore in order to avoid it, basically we'll be trying to get the final image at infinity only. Okay, that means the eye can be in relaxed state. Now, for the first part, you know, formula for magnification m. It will be again in p by u only, but on simplification we get p by f. Okay, this formula is there in the textbook. In fact, while discussing theory, derivation has been made. Therefore, v and derivation is there in the notes also. That is m is equal to 1 plus d by f. Therefore, 8 is 1. This is 25 divided by f. Therefore, 25 by f is equal to 7. This implies f equals 25 by 7. Okay, this comes out to be 3.57. Means a lens of convex lens of shorter focal length can always be used as a simple microscope, and here the focal length is 3.57 centimeters. Okay, this is the first one. Part of the problem. But in the second case, for v equal to infinity, the formula for magnification becomes simply d by. Okay, that means magnification in case of this position will be 1 less compared to the previous one. Okay, 1 plus d by f is there, but here only d by f. But we have to find out m. D value is 25. The value is 3.57. Therefore, this is 7. And the magnification is 7. Magnification that we get for the final image at infinity is 7. Yes. These are the two formulae that we come up across in simple microscope. Okay. Remember the formula. Now, 16. Compound microscope. Compound microscope. Second problem. The 16th problem. A compound microscope, already you know, consists of two lenses. One is objective lens, another one is eye lens or eyepiece. The compound microscope has objective lens of focal length 2.5 centimeter. On the data. Focal length of the objective lens is 2.5 centimeter. Eyepiece of focal length 5 centimeters. Tube length has been given, and it is L, and this has been given as 20 centimeters. And the least distance of this tube division is 25 centimeters. Find the magnifying power of the compound microscope. The first one, when D is at D, it is least distance of distribution. And in the second case, again we have to find M. But now we should be in, that means in both simple microscope as well as compound microscope, we will be coming across these two cases. It is V is equal to B and V is equal to infinity. Okay. Now, in case of compound microscope, magnifying power of the compound microscope is nothing but magnifying power of the objective and magnifying power produced corresponding to eyepiece, M0, MO into ME. But once you consider MO, it will be equal to L divided by M. That is tube length, which will be the distance of separation between the second focal length of the objective lens and the first focal length of the eyepiece. That is L divided by F0. And already it has been discussed in theory that for the eyepiece, or the eyepiece will be behaving like a simple microscope, but the object in this case will be the image produced by the first lens, that is objective lens. Objective lens, the object image barutto, adu object ag work agutte for the eyepiece, but the eyepiece will be simply working as a simple microscope. That means it magnifies the image and it produces virtual magnified image of the real image formed by the objective lens. Okay, that's why the formula for magnifying power is 1 plus B by E. Okay, the first one again. You can easily write down this, and this is for B is equal to capital E. That means if the final image is being produced at least distance of distribution. Now L is 20 by 2.5 into 1 plus 25 divided by 5. Therefore, it is 8. And this is 6. Therefore, magnifying power is 48. That means whatever an object we face in front of the compound microscope, the image size will be 48 times the size of the object. That is the magnifying power of the compound microscope for this position. That is when final image is the least distance of distribution. But if the same image is obtained at infinity, in the formula for this remains the same, but this one has to change, and therefore becomes equal to L by F into B by F E. Okay. Therefore, L by is 25.5, and this is 25 by 5. And this comes out to be 8 into 5. That is 1. In case of least distance of distribution, the magnification is 48. For infinite distance, it is 40. Okay. A small variation, a variation of 8 is there in terms of magnifying power. Okay. These are the two formulae related to compound microscope. In fact, in competitive examination, coming across even some complicated problems also. But this is for theory, definitely question can be asked. Till now, question has not been asked, but there is always a possibility of asking a question related to this one. Now, and the third optical instrument that has been discussed, is telescope. Now let us consider one problem related to telescope also. This 17.1. This is problem on telescope. Diffraction type telescope we are considering. A small telescope has an objective lens of focal length 140 centimeter. This is another important point you have to remember. In case of simple microscope, focal length will be less. In case of compound microscope also, the focal length will be of smaller values. But in case of convex, these telescopes, objective will be having higher focal length. Focal length will be more. Objective focal length 140 centimeter. That is f naught equal to 140 centimeter. Eyepiece of focal length 2 centimeter. What is the magnifying power of the telescope when the final image is at infinity? Magnifying power we have to find out when V is equal to infinity, and also we have to find out the magnifying power when V is at least distance of distribution. And one more quantity has been asked: what will be the separation between the objective and the eyepiece if the final image is at infinity? Okay, that means we have to find out the separation between eyepiece. Okay, this separation we want for final image at infinity. Final image of infrared, what will be the separation between objective lens and eyepiece? Okay, eyepiece to objective to madhya separation is to the okay, this is the thing. But one important thing is, in order to get the final image at infinity, the image formed by the objective has to be obtained at the principal focus of this eyepiece. If this is f naught, this will be f3. Only when this condition is there, it is possible to get the final image at infinity. Because once an object is placed at the principal focus of a lens, the final image will be at infinity. Okay, that's why if the position of the separation between the two lenses is adjusted such that the image produced by the object is formed at the principal focus or the focal point of the eyepiece, then automatically image will be produced at infinite distance. Therefore, the separation is nothing but f4 plus f3. Okay, if I am calling this as x, this x will be equal to f naught plus f. Okay, now let us come to first of all the magnifications. Focal length, it is 140, it has been given. But once you consider the final image at infinity, magnification is simply equal to f naught by f. It is angular magnifications will be coming across in case of telescope. In case of microscope, linear magnifications will be considered. Therefore, f naught by fe, therefore it is 140 by 2, which is 70. Okay, 70 is the magnifying power of the telescope when V is equal to infinity. But once V becomes equal to capital D, magnifying power becomes equal to f naught by fe into 1 plus fe by d. Okay, this is formula that you will be getting. In fact, in the textbook they are not given, but some competitive examination the question has been asked. Therefore, I am writing the formula f naught by fe. The only thing is here reversal is that. Okay, previously compare ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಅಲ್ಲಿ ನೋಡಿ values ಗಳನ್ನು ತಗೊಳ್ತಾರೆ. ಇಲ್ಲಿ f naught fe, ಇಲ್ಲಿ fe by d will be getting. Okay, but one important thing is this is the dimensionless quantity. ಈ ratio below ratio cancel ಆಗುತ್ತೆ, ಒಂದು ನಂಬರ್ ಬರುತ್ತೆ. ಹಾಗಾಗಿ ಅದೊಂದು ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. ಬೈ ಮಿಸ್ಟೇಕ್ f naught into fe ಹಾಕೊಳ್ಳೋದು ಆ ತರ ಆಗಬಾರದು. Now this is equal to 140 by 2 into 1 plus 2 by 25. 47 1 plus 0.08 17 to 1.08, which is 75.6. This is the magnifying power. Look at this, the problem related to telescope. The next video, after the discussion of reflection, okay, will be preparing one more video related to reflection problems. Okay. Therefore, 17 different problems have been discussed. Go through the video. Some problems have been given for practice. Practice them. Now, it is clear. Guidelines for the final paper has been released yesterday. Already you know, in part A, 15 questions will be there. Instead of 10, usually 10 questions were being asked, but now this year, 15 questions will be there and you have to answer 10. Okay, that means extra 5 questions are there. And in part B, 5 questions you have to answer, but 2 mark, but 10 questions. Okay, definitely 14 chapters are there in the NCERT textbook corresponding to the 2 volumes. Out of those 14 chapters, in part A, part B, questions will be there. Okay, there is no specific, okay, there is no specific guidelines for considering first question from this chapter, second question from this one. Okay, some such guideline is there for physics paper. Okay, that you have to remember. And in part C, which is 3 mark question, again 10 questions will be there and you have to answer 5. Again, there is no fixed guidelines. But when you consider part D, 3 parts are there. There are 3 mains are there. Main 4, 5th main, that is 4th main, 5th main, and 6th main. Okay, these are all 5 mark questions. First 2 are theory questions. First 2 mains are related to theory question. The 6th main is related to problems. And in 4th main, where 5 mark questions will be there, 5 marks questions, that is 4th main. Part A, 15 questions. Part B, 10 questions, 25. Part C, 10 questions, 35. Therefore, in 4th main, 36, question number 37, 38, 39. Okay. Out of these 4, you have to answer 2. 2 out of 4. But once you consider this main, here from the first chapter, that is electric charges, 2. Okay, electric charges and fields from this chapter to the next, that is electromagnetic induction. Okay, up to EMI. Okay, this 2 chapter, the questions, the knowledge questions pick up. Okay, this is a very, very important idea that you have to remember. Volume 1, okay, but up to electromagnetic induction. From these chapter, from electric charges and fields to electromagnetic induction. From these chapters, that is electric charges and fields, electric potential and capacitors, current electricity, moving charges and magnetism, and then magnetism and matter, and then electromagnetic induction. Okay, out of 6, from these 6 chapters, 4 questions will be asked. Okay, and in 5th main, we come across question number 40, 41, 42, 43. Okay, and again here you have to answer 2 out of 4. In this one, these questions will be considered from the chapter AC, okay, and then volume 2. Okay. volume 2 and AC. Related to this will be coming across the questions. Okay, ಇಲ್ಲಿ ತನಕ ಬಂದಿರುತ್ತೆ questions. So this note volume 2 now. And in 69, okay, come across from questions 44 to 50. Okay, ಇದರಲ್ಲಿ ಇದ್ದಾಗ 44, 45, 46, 47. Okay, ಈ 4 ಪ್ರಾಬ್ಲಮ್ಸ್ ಈ ನೇಮಲ್ಲಿ ಇರುತ್ತೆ 49, 8, 49, 50. ಈ 3 ಪ್ರಾಬ್ಲಮ್ಸ್ ಈ ಮೇಲಿಂದ ಬಂದಿರುತ್ತೆ. ಅಂದ್ರೆ AC to AC including volume 2. AC ಚಾಪ್ಟರ್ ವಾಲ್ಯೂಮ್ 2 ಇಷ್ಟು ಸೇರಿ ಈ 3 ಪ್ರಾಬ್ಲಮ್ ಬಂದ್ರೆ ಈ 6 ಚಾಪ್ಟರ್ ಇಂದ ಈ 4 ಪ್ರಾಬ್ಲಮ್ಸ್ ಪಿಕ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಹಾಗಾಗಿ ಈ 4 ಚಾಪ್ಟರ್ ಪ್ರಾಬ್ಲಮ್ ನೇ ಫುಲ್ ತರವಾಗಿದ್ರು ಕೂಡ ಯು ಕ್ಯಾನ್ ಆನ್ಸರ್ 3 ಬಿಕಾಸ್ ಯು ಹ್ಯಾವ್ ಟು ಆನ್ಸರ್ ಜಸ್ಟ್ 3 ಔಟ್ ಆಫ್ 7. 7 ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ ಬಟ್ ನೀವು ಆನ್ಸರ್ ಮಾಡಬೇಕಾದ್ರೆ 3. ಹಾಗಾಗಿ ಈ ಗೈಡ್ಲೈನ್ಸ್ ನ ಕೊಟ್ಟಿದ್ದಾರೆ ಈಗ ಮಾಡೆಲ್ ಪೇಪರ್ ಗೆ. ಈ ಗೈಡ್ಲೈನ್ಸ್ ನ ಫಾಲೋ ಮಾಡಿಕೊಂಡೆ ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್ ರೆಡಿ ಆಗುತ್ತೆ. Therefore now you can make some choices, but it's better to read all, especially if you are preparing for competitive examinations. Okay, thank you.